Today we study chapter 10. So until now we studied consumer theory and forms theory when the market is perfectly competitive. Okay, so traditional microeconomics, finish it. Okay, but especially forms behavior different when market structure changes. So the part 1 was consumer theory. Part 2 is production theory when the market is perfectly competitive. Part 3 is firms behavior when market is not perfectly competitive. Okay, so here several chapters, but we studied chapter 10, market power, monopoly, and monopsony. And chapter 11 skipped, and we go chapter 12, monopolistic competition and oligopoly. Monopolistic competition and oligopoly. Chapter 10, monopoly and monopsony. Okay, then we go chapter 14, market for factor input. That is also traditional theory, right? Market for factor inputs. When the market is perfectly competitive, at the same time, market is not perfectly competitive. So chapter 14 is extension of chapter 18 of Menkew's Introduction to Economics book. We cover 3 chapters, 10, 12, 14. Okay? Now we go chapter 10. Structure of chapter 10 is like this. Monopoly power. So monopoly means in the industry there exists only one firm, one supplier. So monopoly power, in that case, monopoly firms have a market power, can increase its price, right? So influence on market price. So over marginal cost. When the market is perfectly competitive, think about price is equal to marginal cost. That is profit maximization condition, right? But market is not perfectly competitive. Firm can charge higher price than marginal cost. Marginal price higher than marginal cost. Okay? But marginal revenue is equal to marginal cost. That is same. But price higher than marginal cost. Right? That is monopoly power. Sources of monopoly power and social cost of monopoly power and monopsony. Monopsony means some purchasers have some power, right? There are lots of suppliers, for example, but only one consumer demand everything. Then in that case also, so purchasers have some power, monopsony power, okay? So, blah, 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 okay? So, first example, monopoly, market with only one seller. Monopsony, market with only one buyer, okay? Market power, ability of a seller or buyer to affect the price of a good. Influence on the price. Next slide. Section 1, average revenue and marginal revenue. Marginal revenue, change in revenue resulting from 1 unit increase in output. Consider a firm facing the following demand curve. Price equal to, so demand curve is price is equal to 6 minus Q. 6 minus Q. That is demand curve or price curve or average revenue curve, right? Like this. Then we can calculate total revenue, price multiplied by Q by this. In this example, price decrease and decrease as Q increase, right? So similarly, we can calculate the marginal revenue, the gap between the two, okay? Average revenue is total revenue divided by Q. That is definition of average revenue. graphically like this. Average revenue is like this. Then marginal revenue is like this. Right? So now price is 6 minus Q. Then total revenue is price multiplied by Q. Right? That means 6 minus Q over Q. In other words, 6Q minus Q square. That is total revenue. Right? Average revenue is total revenue divided by Q. That means total revenue is 6Q minus Q square over Q. Right? So then what happens? 6 minus Q. That is average revenue. Marginal revenue is change in total revenue divided by change in Q. First derivative instant slope is D, right? Change in R over change in Q. First derivative of total revenue function with respect to Q. That means, right? Change in 6Q minus Q square, that is revenue, DQ. First derivative of this one with respect to Q. Then what happens? First derivative is 6Q, only 6 left. Q square, 2Q, right? That is first derivative, first differentiation of, first derivative of original revenue function is this one, right? That is marginal revenue curve. Graphically, marginal revenue curve is this one. Q equals 3, then marginal revenue is equal to 0, right? Q equals 0, then marginal revenue is 6. So we can get this kind of marginal revenue curve. Similarly, average revenue curve. Q equals 6, then average revenue is equal to 0. Q equals 0, then average revenue is 6. That is average revenue curve. Okay? That is figure 10.1. Okay. The monopolist's output decision. Profit is maximized when marginal revenue equals marginal cost. Same. Profit maximization condition is marginal revenue is equal to marginal cost. Okay? That is same in when the market is perfectly competitive, marginal revenue is equal to marginal cost. Okay? When the market is perfectly competitive, marginal revenue is equal to price. That is profit maximization condition when market is perfectly competitive, right? But here, marginal revenue is equal to marginal cost. That is profit maximization condition. And we know that price is higher than marginal revenue, right? Average revenue greater than marginal revenue. Price greater than marginal revenue. Okay? So when the market is perfectly competitive, like this, right? Market is not perfectly competitive, this condition is satisfied. Anyway, profit maximization condition said this one, right? This one. Profit maximized when marginal revenue equals marginal cost. In this example, average revenue curve, marginal revenue curve, marginal cost curve. Right? So firm produce Q star to maximize profit, where marginal cost curve is equal to marginal revenue at this point. Right? And charge price. What is price? Price is average revenue, right? When producing Q star, price is equal to this one, P star. Can you understand? Right? Q star is the output level at which marginal revenue is equal to marginal cost. If the firm produces a smaller output, say Q1, then what happens? It sacrifices some profit because the extra revenue that could be earned from producing and selling the unit between Q1 and Q star exceeds the cost of producing them. Similarly, expanding output from Q star to Q2, more production than Q2, then what happens? Right? Then this area is lost profit from producing too much. Okay? And next slide. You can also see algebraically that Q star maximizes profit. Profit pi is the difference between revenue and cost, right? Profit, I'd like to rewriting this. I give us some numerical example here, right? Anyway, more generally, profit is revenue minus cost. Revenue is function of Q. Cost is also function of Q, like this, right? As Q is increased from 0, profit will increase until it reaches the maximum and then begin to decrease. Thus, the profit maximizing Q is such that the incremental profit, in other words, marginal profit, is equal to 0. Okay? This is perfectly same. Change in profit over change in Q, that is marginal profit. That is change in R over change in Q minus change in C over change in Q, that is equal to 0. Right? Same to, so change in R over change in Q is marginal revenue. Change in C over change in Q is marginal cost. So profit maximization condition is marginal revenue is equal to marginal cost. Graphically, this kind of thing. Here, cost function C, total cost is equal to 50 plus Q square, right? And demand curve PQ is equal to 40 minus Q. Okay? So like this. Then from here we can calculate total revenue. Total revenue is price multiplied by Q. Price equal to 40 minus Q multiplied by Q, PQ. That is total revenue, right? Then total revenue is 40Q minus Q square. Okay? So from here we can calculate the average revenue and marginal revenue. Average revenue is this one divided by Q. So 40 minus Q, right? Marginal revenue is first derivative of this one with respect to Q. So then what happens? First derivative is 40 minus 2Q. That is marginal revenue anyway from this one. Okay? Also think about profit. Profit is equal to revenue minus cost. Total revenue is 40Q minus Q square. Minus cost, total cost is 50 plus Q square. Then what happens? 40Q minus Q square minus Q square. So minus 2Q square plus 40Q minus 50. That is total, that is profit, isn't it? Right? That is profit. Then marginal profit, or first order condition, profit maximization is first derivative of this one should be equal to 0, right? Then, how can I say? First derivative, change in profit or change in Q is, the first partial derivative of this one is minus 2 minus 4Q, right? Plus 40 should be equal to 0. Right? Then what happens? Profit maximizing quantity should be equal to 10. Right? And then price is equilibrium price is Q equal 10. So price should be equal to 30. Like this. Right? That is profit maximization. We can calculate it like this, mathematically. Right? Or think about first order condition, we said marginal revenue is equal to marginal cost. Okay? From this cost function, we can calculate the marginal cost. From here, this implies that marginal cost is the first derivative of total cost with respect to Q, right? What is this? Marginal cost is 2Q, isn't it? Right? The marginal revenue is equal to 40 minus 2Q, right? And marginal cost is 2Q, right? Then 4Q is 40. So Q star is 10. Same, right? There are two ways to calculate profit maximizing price and quantity. First, profit. Construct a profit function, and first derivative should be equal to 0. So we can calculate like this, right? The other way, just focus on first of the condition. Marginal revenue should be equal to marginal cost from this function, right? Then we can calculate Q star equal 10, P star equal 30. Can you understand? The number one way, profit function is profit, right? Now think about revenue function shaped like this. That is RQ, right? And cost function is like this. That is cost function, right? Revenue function is this one. Cost function is this one. From here, we can calculate the profit. Graphically, profit is the difference between revenue minus cost. So cost profit function is this point, negative, right? And profit maximized at this point. Profit and like this. That is profit function, right? That is profit function. And we know profit Q. Profit maximized when you produce Q star. Okay, graphically. At here, what happened? When profit maximizes, first derivative should be equal to 0. That is this one, right? Then we know Q star equal 10, P star equal 30. Got it? That is first way. And second way of calculation is like this. From this graph, right? That is the revenue function, right? From here, we can calculate average revenue and marginal revenue, right? Average revenue and marginal revenue, okay? So, average revenue and marginal revenue. That is, for example, average, that is marginal revenue, and that is average revenue, or price is equal to 40 minus Q like this, right? And marginal cost is 2Q, so like this. That is marginal cost curve, right? Also, we can draw average cost curve. Average cost curve is, for example, like this. That is average cost curve, right? That is average cost curve. So profit maximization condition said marginal cost is equal to marginal revenue. That is Q star. And price, that is Q star. And price is this one, P star. Right? That P star is 30, Q star equal 10. Okay? So I'd like to explain two ways to solve problem. Right? Graphically and mathematically. There are two ways. That is explained here. Anyway, from here, profit is this one. When you produce Q star or 10, price is P star equal $30, Q star is equal 10. When you're producing this one, total revenue is P multiplied by Q. So this area is me. Right? Anyway, like this. Total revenue is PQ. Total cost is what happened? Total cost is equal to average cost multiplied by Q. That is total cost, isn't it? Because average cost is total cost divided by Q, multiplied by Q, then total cost left, right? So we can say average cost multiplied Q. That is profit, right? Then we can rewrite like the P minus average cost Q. Okay? Price minus average cost Q. That is profit. So when you produce Q star, average cost is here. Right? That is average cost. when producing Q star, right? And we know price greater than average cost, and you produce Q star. So this is profit. Can you understand? So positive profit if price greater than average cost, right? So in this graph, price greater than average cost, then positive profit, right? Next slide. A rule of thumb for pricing. With limited knowledge of average and marginal revenue, we can derive a rule of thumb that can be more easily applied in practice. First, write the expression for marginal revenue, blah, 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 like this. Note that the extra revenue from incremental unit of quantity, that is this one, change in total revenue over change in Q, has two components. Producing one extra unit and selling it at price P brings in revenue like this. But because of firm faces downward sloping demand curve, when the market is perfectly competitive, average revenue curve horizontal line, marginal revenue comes into that is demand curve, price curve, right? Three things are same, but here different. Okay? So, but because of firm face a downward sloping demand curve, producing and selling this extra unit also result in small drop in price, which reduces the revenue from all units sold. All units sold at lower price than before. So marginal revenue is like this, right? So what is this? Okay. Marginal revenue. Okay, I'd like to explain. So now think about what is marginal revenue is change in total revenue. That is PQ divided by change in Q. When the market is perfectly competitive, price is just constant numbers. But not anymore. When the market is not perfectly competitive, price is also a function of Q. Okay, so this one, more exactly talking, price is not constant. Now variable. So that is function of Q multiplied by Q. Okay? Then think about total differentiation of total revenue with respect to Q. Have two components. Number one component is, well, this one considered as constant. This is a variable, right? Then, how can I say? Round total revenue over round Q. I'm sorry. This part considered constant, this one variable. That is number one component. Second component is, this is variable, that is just constant numbers. Okay? Then first case, then only Q left. Okay? I'm sorry. Then this one variable, this one constant. So changing Q disappeared. This one is constant number, so just P left. That is first component. Second component is Q considered constant. This one variable. So change in P, change in Q. We can rewrite this. Right? The two components. Right? That is explained here. Right? Okay. From here, this one can be, okay, starting from here, this one. So rewriting this one like this, case number one. Right? We can rewrite like that. Price Q divided by Q. Oh, can I say? Get this. Okay, P divided by T. Q change in P, change in Q. Right? This one is perfectly same to this one. Right? Multiplied by price and divided by price. Then same to earlier one. That is marginal revenue, isn't it? Marginal revenue is like this. Okay? This one really written like this. Then we know, what is this? Think about this. What is this? That is reverse of price elasticity of demand, isn't it? Right? So, what is this? Price elasticity of demand is equal to change in P, change in Q, Q over P. P over Q. This one is just the opposite of this one. Right? In other words, price multiplied by 1 over price elasticity of demand. Right? You can see it like this. Right? Then, like this. Also, we know that when the profit maximization condition, marginal revenue is equal to marginal cost, right? Then we can see this one. This one is same. Then what happened? Price minus marginal cost moving inside of this, then minus price 1 over price elasticity of demand. Right? Price minus marginal cost is equal to minus price 1 over price elasticity of demand like this. And divided by price, then what happens? Price minus marginal cost, price, right? Is equal to this one disappeared, only this one left, or minus 1 over price elasticity of demand. Right? We can find this kind of relations. That is equation 10.1. Okay? Okay, then what is this one? Equation 10.2. Equation 10.2. Equation 10.2 is from, anyway, starting from here, that is number 1. And following this one, we can get these relations, right? That is 10.1. 10.2, anyway, starting from here. 10.2, starting from here. This one, now think about what is this? This kind of thing, right? Okay. This one is like this. This one. From here, marginal revenue is equal to this one. Price, we can rewrite like the price 1 plus PP, 1 over price. Q, change in P, change in Q. Right? Marginal revenue is equal to P plus Q like this. So this first component is this one. Second component is this one. Q over change in P, change in Q is price divided by price and multiplied by price. So we can rewrite like this, isn't it? Right? Okay, so this one, rewriting this one is just Q over P, right? And earlier that this case, this is a reciprocal value of price elasticity of demand, isn't it? In other words, marginal revenue is equal to price 1 plus 1 over price elasticity of demand. right? Marginal revenue is equal to like this. Similarly, in the earlier case, marginal revenue is equal to marginal cost, like this, right? Then from here, price. This price is equal to marginal cost divided by 1 plus 1 price elasticity of demand. We can get this kind of relations. Okay? That is equation 10.2. Right? 10.1 and 10.2 is anyway same thing. Right? And sometimes this equation 10.1 is very useful because from here we know that price minus marginal cost over price. Price greater than marginal cost. Then this is an indicator of monopoly power. Some power charge higher price than marginal cost. Okay? So that is index of monopoly power. Right? So in the next section, we said this one is learner's index. Okay? So that is equation 10.1. And the other is this one. That is 10.2. This is very useful when we some studies monopoly pricing and calculating market power. Right? So that is 10.2. So next slide. So now look at this example, right? Extra milk prices Prilosec. Prilosec is anti-ulcer medicine, right? In 1995, Prilosec represented a new generation of anti-ulcer medication. Prilosec was based on a very different biochemical mechanism and was much more effectively than earlier drugs. So the company have some market power to sell this new drug. By 1996, it had become the best-selling drug in the world and faced no major competitor. Extra Merck was pricing Prilosec, charging monopoly price at about $3.50. Right? Price was $3.50. $3.50. Right? The marginal cost of producing and packaging Prilosec is only about 30 to 40 cents. Marginal cost is 30 cents to 40 cents. Right? But charging higher price. Price is really expensive than compared with marginal cost. Price minus marginal cost. Large gap. Right? Setting the price at a markup exceeding 400%, I think 900% over marginal cost is consistent with our rule of thumb for pricing. How? Now think about this one. We use 10.2. Right? Now think about, right? Here, where is price elasticity of demand is, right? Price elasticity of demand is minus 1.02 minus 1.2. So we just fingerprinting at minus 1.1, right? That is price elasticity of demand. We have information for this one is minus 1.1, right? And price is like this. If we have information for this, we can rule up some monopoly price, actually. Right? So now that is minus 0.1. Now think about this term. Right? Minus marginal cost over 1 plus price elasticity of demand. And we know that is minus 1.1. Right? Then this one can be rewriting minus sign moving here. Then 1 minus 1 over 1.1. Okay? Now think about 1 divided by 1.1. What is this? Then 1 over 1 divided by 1.1. then that is approximately about 0.9, right? So that is, in numbers, 0.9, right? Like this. 1 minus 0.9 is 0.1 marginal cost. That is equal to, multiplied by 10, then price equal to 10 marginal cost, right? That means 1 plus 9 MC, or 1 plus 900% marginal cost, right? So 900% over marginal cost. Markup is 900% instead of 400%. Okay? So this kind of sum is also very important. So you fully understand how to calculate this kind of thing. Anyway, we studied this one more time in next section. 10.1, shifts in demand. A monopolist market has no supply curve. In other words, there is no one-to-one relations between price and the quantity produced. Why? Price is also a function of Q. Price and quantity decide this jointly. Okay? The reason is that the monopolist output decision depends not only on marginal cost, but also on the shape of the demand curve. As a result, shifts in demand do not trace out the series of price and quantities that corresponds to a competitive supply curve. Instead, shifts in demand can lead to change in price with no change in output, change in output with no change in price, or change in both price and output. Okay? Shifts in demand usually cause change in both price and quantity. So price and quantity changes simultaneously, actually. A competitive industry supplies a specific quantity at every price. No such relationship exists for monopolists, which, depending on how demand shifts, might supply several different quantities at the same price or same quantity at different prices. So look at this. Figure 10.4, shifts in demand. Shifting the demand curve shows that a monopolist market has no supply curve. There is no one-to-one relationship between price and quantity produced. So there are three cases, and this graph explains first case and second case. But in real world, both of two cases, right? So price and quantity jointly decided. Anyway, now look at these two cases as just to get some insight. Okay, the first case original demand curve, marginal demand curve, marginal cost. So equilibrium price is here, where marginal cost is equal to this one. But demand shift D2, then D2, then marginal revenue is now right there. D1 MR1, D2 MR1, right? So MR1 is equal to marginal cost. So price is same, quantity same, but price increased to P1. P lowers to P2. Okay? So output same, only price changes when demand decreases in this example. And next example is marginal cost, just different. Originally, marginal cost D1 MR1. So MR1 MC1 and price is equal to P1. Okay? But now D2 MR2. So MR2 is equal to MC. So production increases Q1 to Q2. And price is P2. But P2 is equal to P1. So second case means price, no change in price, only production increase. Section 1, panel 1 is the opposite case. Production same, but price changes. But in real world, two things happen simultaneously. Right? Okay, the effect of tax. Suppose a specific tax $T per unit is imposed, so the monopolist must limit $T to the government for every unit it sells. if a marginal cost was the firm's original marginal cost, its optimal production decision is now given by marginal revenue is equal to marginal cost plus T, tax. Okay? Demand curve, marginal revenue curve, and marginal cost curve originally like this. Now, imposition of tariff, output tax, marginal cost curve plus tariff is now here. Right? Then, in earlier section, marginal revenue is equal to marginal cost. So, firm's production, optimal production is Q0. But what happened after output tax? Right? Marginal cost is equal to marginal cost. New marginal cost is equal to marginal revenue. So production decreased greatly, isn't it? Right? So that is explained here. With the tax T per unit, the firm's effective marginal cost is increased by the amount T to MC plus T. In this example, the increase in price change in P is larger than the tax rate. Tax rate is MCT, the gap between the two marginal cost curve, right? That is T. But price increase greatly when the market is monopoly, imperfect, right? Okay, I'd like to stop here.